Hey, welcome back for more AP Chemistry. This is podcast 11.3. We're talking about acid-base equilibrium, and I want to show you how to handle a mixture of weak acids. So if we have a mixture, the process of dealing with Ka doesn't really change. We determine the major species and then decide which ion will predominate. And of course, it's the one with the bigger value of Ka. That will determine our pH. So we have a mixture of hydrofluoric acid, which is a weak acid, and benzoic acid, also weak. Since the Ka of HF is much larger than the Ka of benzoic acid, I suspect this will have the most influence on our pH. But let's see how to work this through. So let's start with our equation that describes the equilibrium when the weak acid is placed in water. So we form the hydronium ion and the anion. So here's my acid, and this is what's called its conjugate base. And we'll set up a rice table to describe what's happening with HF. We started with 1.2 molar, and water doesn't get to be in my expression, so we ignore that. The hydronium ion and the fluoride ion would have a 0 concentration for the initial conditions, but I will lose some of my acid as I produce hydronium ions and fluoride ions. So in the equilibrium value, I have 1.2 minus X for HF, I have X for hydronium, and X for fluoride. Now the Ka is equal to the concentration of the products over the concentration of the reactants. Which in this case will be x squared, x times x, right, over 1.20 minus x equal to the value of Ka of 7.2 times 10 to the minus 4. And that's a small enough value that we can use the small x assumption that this is really not going to make much of a difference. So multiply 1.20 across and take the square root so that we can get the value of x. 7.2. So we take the square root of 7.2 times 10 to the negative 4 multiplied by my initial concentration that was 1.2. So x is 0.029. So that means that the concentration of hydronium ions from HF is equal to 0.029 molar. But that's not the only source of hydronium ions in my solution. We also have benzoic acid. So let's write out that reaction, forming hydronium ions from benzoic acid and leaving me with benzoate ions in solution. And I'm going to put the negative by the oxygen where it actually hangs out. So there's the R. Let's do the rest of our rice table. And I started with 3.4 molar, so it's like 3 times as concentrated as the HF. But since it's so much weaker, I think HF will still make more of a difference here. So I subtract X from reactants, gain X in my products, and I get 3.4 minus X, X, and X. So our other Ka gives us the hydronium ion concentration times benzoate ion concentration all over the benzoic acid, which is, in terms of the equilibrium values, x squared over 3.4 minus x, and that has a value of 1.6 times 10 to the minus 10. So we'll solve for x in a similar way. We definitely have a very small Ka. So the X we say is too small to count. So I multiply that across and solve for X. So I need to take the square root of 1.6 times 10 to the minus 10, 10 to the minus 10, yep, times 3.4. So now I have two sources of hydronium ion concentrations. I have some hydronium from benzoic acid, and I also have hydronium ions coming from the HF. So I'm going to add those two together and calculate my pH. So let's just take what we had before and add the hydronium ion concentration from HF to it. As many sig figs as you think you need to have an accurate response. So 0.029, yeah, that didn't really change things, did it? And then to find the pH, what do? pH means take the negative log of the hydrogen ion concentration. Our hydrogens are all stuck to the water in this hydronium thing, so I do the negative log of 0.02947, blah, blah, blah. And I don't like rounding until I have to, so I do the negative log of the answer we got before. So that gives us a pH value of 1.53. And we'll just call it 1.5 because we only get to keep two sig figs. So the pH is 1.5 for this mixture of two weak acids. And that's how you do mixtures of things. You just add up what you get from each different thing and we work it out. So we'll see you guys in class.